Yeah.
Right. Good afternoon, everybody, and welcome to this session. So if you're working for an industrial manufacturer or maybe an energy and utilities company, or just interested in what private 5G and digital twins along with AWS can help you optimize your operations, then you're in the right session. My name is Krishnadhar Dupaneni. I'm the worldwide technology leader for industry partners in IoT. And as Dr. Purav mentioned, I was in Middlesex alumni 10 years ago. Firstly, let's start with a question. So how many of you believe that existing companies will still be here in 10 years if they don't change their data strategy? It's an obvious question, and the answer is obvious as well. So 45% of the CEOs agree that companies will not exist in 10 years if they don't change with the times. And 56% think that operational agility is a critical factor to enable their organizations to change as well. In the manufacturing and industrial sectors, we think of operational agility being delivered by Industry 4 projects or smart manufacturing projects. So let's look at smart manufacturing today from the lens of AWS. The International Society of Automation thinks about it in the terms of improving performance through integration and intelligent use of resources, but also collaboration across different domains that you may not have collaborated with before across your entire value chain. This performance could include agility, but also safety, efficiency, and sustainability. And other domains could be engineering, logistics, marketing, anything, just anything outside the production line. Looking at this in a different way, it's about the ability to be able to see real-time data for visibility on the shop floor, to be able to respond in order to optimize your machines for efficiencies across energy or productivity. And then it's also being able to predict the future to maximize your availability and optimize your yields. People that do this right are achieving up to 20% of productivity improvements and 10% in energy reduction, so much as 70% of manufacturing firms have already started a smart manufacturing project or will do in the next 1 year. It's obvious that it's going to be underpinned by data, and manufacturers have a lot of it. It is estimated that 1,800 petabytes is being generated every year, and 90% of it remains siloed. That is the major problem. 70% of the projects are failing to deliver a fully potential. And if we drill this down, 40% say the main problem is with integration. When I say integration, this is integration of legacy equipment and protocols. We do have the ISA 95 standard, but I honestly believe it's a little bit out of date and encourages those silos, which means it is causing data to be localized. And the problem is data formats are inconsistent. Solutions aren't being repeatable, and the data is not being democratized across the board. This also brings connectivity in dead spots in factories, which are from fixed legacy cabling, and security fears also hampering data capture from the edge, from sensors, machines, and controls. Today, we're going to help you solve that integration challenge by introducing an industrial data foundation. We're going to look at 3 key use cases that customers come to us for help with. Then I'm going to talk to you about that connectivity decision making right through our partners in the UK there. So let's start today by talking about the typical edge to cloud journey and an industrial edge foundation that can help with that. A typical industrial journey starts with the industrial edge, with machines, sensors, and controllers emitting data at the edge. These machines and sensors are emitting data, but in order for an operations detector to turn that into insightful changes, that data needs to be ingested at the edge. And maybe you might need to do some transforms, some buffering, some compression before you send that data into the cloud for ingestion and storage. Now, in order to make sense of that raw telemetry, you need to add context to that data to make sure it makes sense with your organization and makes sense with all the people that are going to need that data for their uses. Once it's understood, you can start to run predictions and maybe use machine learning or traditional physics models to be able to simulate it what if analysis in the future. You may also want to visualize that data to bring human mind into play and visualize it through 2D, 3D, or even 4 dimensions across time. And once you have decided what optimizations you want to make, you need to get that data back to the edge in a safe and secure way so that it can be applied to the line itself. All of this needs to be underpinned by reliable and secure connectivity at the edge as well. Otherwise, you're not going to get anywhere. Thinking of this in a technical domain, there's an awful lot of functionality you need to deal with across a whole number of tiers before you get into that insights. So instead of walking you through the stack, I'm going to take you through a number of key use cases and explain the architecture that's underpinning it to build up an overall simple starter architecture for you. So let's start with the main thing. Customers come to us with an industrial scenario, and it's being able to make their data from production line and to bring it to able to be monitored at a global level. The first example I'm going to take is from the UK again, Kingspan. They're a building group with about 50 factories spread across the world, but each of it has its own individual data capture and collection system. They were struggling with the lack of availability and had a manual process that was generating audits, and this was taking up to 3 weeks to execute. It was very difficult for them to get that data out of siloed historian servers and their manufacturing execution systems. This is restricting their growth and their ability to be able to improve their processes. AWS, together with its premier partner, StormReply, worked with them in order to implement an asset monitoring and prediction solution that was able to ingest the data from the edge and move it to the cloud. This allowed Kingspan to monitor their plants and assets in real time and provide insights on their performance and efficiency across the world to executives, managers, and operators wherever they are. The asset monitoring prediction, also known as AMP, is built on AWS IoT Sitewise, a service of ours, and uses those native services for industrial data using managed Grafana as a dashboarding tool that is integrated with Sitewise. Kingspan can now visualize, query, and run optimizations on their data to understand metrics wherever they are stored, which means their staff at all levels are now able to take data-driven decisions, and those reported up to taking up to 3 weeks can now be generated in just 3 minutes. The solution, which is the IoT in a box that StormReply delivered, can now be rolled out across different factories that are already there and also to new factories that are being rolled out. This is a great example where AWS service IoT Sitewise did the undifferentiated heavy lifting for this customer. Let's talk about that heavy lifting that Sitewise helped with. As an example, consider a global monitoring scenario. The first thing that I want to talk about here is adding context to that industrial data. Raw data streams captured from machinery need to be put in context to be meaningful. And Sitewise helps you with that by creating an asset model. Asset models are abstract definitions which can include properties, measurements, transforms, and alarms. And then you can nest your asset models to build up conceptual structure which represent the way you think about your facility, lines, machines, controllers, and individual sensors. Now, this is really important because you can define metrics in a standard way that can be applied across your organization. So they can compare, like when you're comparing one plant in one country to a different plant in another one. It's important here to note that Sitewise is actually providing the streaming analytics engine to run these calculations on the fly. Now, you could do it all by yourself by using a fully blown analytics pipeline like Kafka or Apache Flink to calculate KPIs on the fly. But that's not going to take a short time. It's going to take a lot of time to build and manage those for common calculations like OEE. Sitewise allows you to just write those calculations and get going. Talking about OEE, if you're not familiar, it's widely used measure for your operations to combine availability, quality, and performance, or even throughput. Once you have defined how your transform and metrics are applied to these models, Sitewise makes the metadata and data available to your organizations through low latency APIs. The other new feature that came through last year is the ability to extract the entire asset hierarchy into just a flat file so that you can use that to promote an asset definition through the development lifecycle, or to take all of those assets from one facility and deploy them, and along with the changes to another one, the other side of the world, without just making any piece of code. So in order to get that data into Sitewise, you're going to need to ingest it. So let's look at a few ingestion patterns that are most common in the industrial language. If you already have connectivity to your sensors, you may be using IoT Core over MQTT over LoRaWAN. There's already a pre-existing connector to Sitewise, so without any code, you can just push it through Sitewise APIs. Or if your data is already sitting in the cloud, you can just push it through Sitewise APIs using the AWS SDK and a Lambda function. However, in the most industrial scenarios, you're going to be sitting behind an industrial network, which is very isolated. Excuse me. Your assets cannot access the internet, so you're going to need an industrial data processing device that is typically inside a DMZ or your local corporate network. In this case, the edge processing device is responsible for collecting all your assets using a variety of protocols, dealing with a variety of frequencies that those assets are emitting across your plant. Your edge processing device then is responsible for buffering those and deal with the different frequencies and send it securely and reliably to the AWS cloud. In the AWS world, that edge processing device is typically called the Sitewise Edge, running on Greengrass. I used the word Greengrass. Let's look at a closer look at it if you don't know what it is. AWS IoT Greengrass is an edge software that's deployed into devices to enable you to deploy components either for a single device or a whole fleet of devices through deployment. It also deals with secure connectivity back to the cloud and can give you extra features like remote tunneling so that you can access your edge gateways behind the firewall. One component that Sitewise uses to deploy onto Greengrass is the Sitewise Edge data collection pack that gives you the capability to connect to a number of industrial protocols like MQTT, Modbus TCP, OPC UA, etc. And then through Greengrass streams, it securely buffers those and then publishes it back to the Sitewise in the cloud. Now, one thing we need to note here is most customers actually need to do stuff at the edge as well. It's not about just extracting the data to the cloud as quickly as possible, but also need to run in an isolated environment. And this is where Sitewise Edge Processing Pack comes into play. This configuration is done from the Sitewise in the cloud. It creates a script for you to run your edge and automatically deploys a processing pack. Alongside the basic components, there's a time series database that you can store data at the edge for up to 30 days so that you can do data processing at the edge initially and then send the processed information to the cloud. The last capability I want to talk about Sitewise is the industrial data platform, is the storage. Once data is in the cloud, Sitewise offers 3 tiers of storage. There's a hot tier for storage available that is for high velocity applications. So it gives you low latency APIs to access the data. We also offer a cold storage that you can configure site-wise every 6 hours to export that hot tier data into a structured set of buckets in Amazon S3, which forms the cold tier storage. Now, this is more appropriate when you want to store data for a long period, but you want to also frequently access it. Recently, we also offered a warm tier. Now, this is a compromise between the two storage tiers I mentioned before, the hot and cold. So it's for frequently accessed data where you can afford to have slightly higher latency, but you want to keep that data, say, for a year or so. This is great for analytics reporting and machine learning, where you want to get data into those tools simply and also quickly, but you don't want to struggle to getting it out of the S3 bucket. Now, next up is to get that data into the cloud and drive those edge connectivity use cases, you need to get your connectivity decisions right. Often we take connectivity for granted until it fails. What if a millisecond latency can save millions on a bladed disk manufacturer from jet engines? Study has identified that use of 5G enabled vibration sensors can detect an anomaly and correct the cutting angle of a CNC machine in a split second to avoid 10% of wastage. This in numbers means 27 million euros to our customer. In the next few slides, let's look at the design for 5G private network, edge computing, and talk about the different trade-offs. Imagine you're in a manufacturing plant, which is a gigafactory. Gigafactories are a very large manufacturing sites for the production of electric vehicles. They need both scale and agility, and while scale is often achieved by automation, wireless connectivity brings agility to support rapid changes on the factory floor. Creating the target architecture is a key to find a solution that fits your needs to avoid redesigning in the future. Too many options, right? There are a lot of options for connectivity, from Wi-Fi to private 5G to LoRa. So we need to understand what our goals are and our use cases are. If you're looking at AGVs that needs high mobility and remote controlled equipment like CNC machines, needs low latency to ensure a smooth control of devices. While connected workers have sensors in their clothing to ensure safety, wireless tablets and other tools for remote worker support. And then we have temperature sensors on the spray booth or just parking sensors. For all of these, we have different options. So what are the trade-offs? LoRaWAN is known for the low battery consumption against its low data rate. Just 1 second. Sorry. So it works best for environmental monitoring and asset tracking. Wi-Fi, on the other hand, is known for high data rates and low latency, but it really cannot be applied for applications with mobility involved. Then there is 5G high data rates and also carrier-grade security, which is perfect for autonomous vehicles and also for remote controlling machines. So let's dive into 5G. 5G is not built only for consumer applications. It has been designed for the industry and manufacturing, so everyone can benefit from it. What are the key features for manufacturing that it can be leveraged? The design for 5G is for mission-critical communications like worker safety, security, and AGVs. 5G is designed to support millions of devices, and the millimeter wave transmits data a lot more faster and enables the millisecond latency. But what about the 5G spectrum efficiency here? 5G has been designed to cover the range of spectrums that has been available in the previous technologies, but also with high bandwidth or the millimeter wave can allow you for high data rates in a short coverage. But this is where, with so many options, we need to take some decisions when designing one. What if I told you you can bring 5G benefits into your factory in a box? So to bring the additional benefits of 5G, allowing data to stay local with edge computing and adding guaranteed quality of service, the architecture reduces silos and network hops that we usually see in factory floor. This adds reliability and redundancy. And to make it secure, harder to hack, keeping these design parameters in mind, the security architecture from 5G spans across the user equipment, radio, and core network. We have dedicated mobile private network that allows for customers to fully control and solution, and the data generated stays on premise, which is often a key manufacturing requirement in industrial use cases. But if we require to have a wider coverage for asset tracking across the country, we rely on hybrid mobile private networks to join the best of the both worlds. We also have network slice where the data and applications run on a private network, on a public network with guaranteed quality of service. And then it can be controlled by our network APIs to meet the requirements of our customers. An example where network slice has been applied is the King's Coronation, where a private 5G network slice has been deployed by a partner in the UK, Vodafone. To take a closer look, mobile private networks are built on key components, including radio units and mobile core and the 5G. Edge computing runs digital apps to further reduce latency from machine controls to provide ensure reliability, both input and output of the data, and making it available on the fly with local dashboards like AWS IoT Sitewise. So the mobile private network here connects to an OT network with sensors and PLCs via the 5G. And 5G is everywhere, which means all the edge devices are now connected on the factory floor. This 5G also connects to high-definition cameras, connected workers with body cams and AR headsets. The AGVs carrying parts from the docks, etc. A managed service from Vodafone allows you to hassle-free experience to focus on your core products. And this is the size of the box I'm talking about that can be applied on a factory floor. To sum up, we've looked at how to get connectivity right, what 5G networks are, what edge computing means, and what trade-offs are made. Now we understand how to connect our assets to get the data to the cloud. The next thing that customers come to us asking for help is the ability to predict future, specifically to look at anomalies and try to understand how to fix their failure problems. Let's look at a customer use case here. This is a very interesting one from Toyota. Toyota Manufacturing in Kentucky runs more than 200 CNC machines per their site, running 24/7. The maintenance team had the difficulty in identifying high priority maintenance tasks and were expecting 40 hours of unplanned downtime every month. They didn't have the in-house skills to build their own solution, that is, building machine learning models or the ability to deal and analyze large volumes of data and spot anomalies before failures from that line. Using AWS IoT Sitewise and Lookout for Equipment, which is an Amazon managed service, they were able to launch a solution that could predict CNC machines' failure days in advance. They now have scaled more than 300 assets across the plant, and Toyota have chosen to roll out this solution across all of North America. How did they do that? It's actually really easy, as Sitewise is now natively integrated with Amazon Lookout for Equipment. Lookout for Equipment is one of our ready-to-use machine learning service that allows you to build anomaly detection models from sensor readings like temperature, pressure, vibration, which you have collected over time. Categorical data like asset types, location, sensor states, and operating modes can also be added into the dataset to provide context around your sensor time values. Now, one thing that made this Toyota customer use case even more interesting is the use of machine state data to assist the anomaly prediction model. While it's very common to use anomaly detection with continuous rotating assets like pumps and motors, this shows, in this example, non-continuous machinery such as Toyota CNC machines can also be included in the accurate state data in your training and inference datasets. Using this ready-to-use integration, you can now focus on operation analyst time on identifying the root cause analysis and optimizing your maintenance team schedules before it stops your line while keeping maintenance costs to a minimum. Like I mentioned before, this Toyota use case is particularly interesting is that we normally associate these types of automatic prediction models with continuously running machine types and sensors like pumps and motors. But here in this case, those CNC machines were switching themselves on and off. So it's a great example of adding extra data in real time and the state of the machine in order to give hints to the neural network when the model's being trained. Now, once the data set has been exposed, Lookout for Equipment will automatically ingest that into its training data set. And when that's done, you will know within Sitewise, you can trigger a training job. Now, it's important to know that which data set to start with. Now, at the beginning, you can start with experimenting and then find out what really works and put that into production. But you probably want to keep retraining over time as different configurations on the production line means those signals mean different things for the user. So this brings the ability to do that from Sitewise is really useful without having to manage machine learning pipelines or any of that type of automations for the customer. Once those inference schedules are triggered in Lookout for Equipment, the results can be detected. The results show the detected anomalies are then sent to Amazon S3. And the state of the asset, whether there's a current anomaly detected or not, is then also integrated into Sitewise, so you can actually see that in your dashboards. So that's how our customers are going and doing predictive maintenance on AWS. So I hope you learned something about AWS Industrial Services that helps customers with accelerating operational excellence. Here are some material and workshops that help you getting going.